Welcome. So this is a quick video on how to do a t-test designed for a course in ecology, something for undergraduates, physiology, something that's not a stats heavy course. Okay, if you're in a statistics course, then you should be beyond this video. This is meant for students in a course where statistics are being introduced and applied but aren't the main focus of the class. So, having said that, I'm going to be skipping some material that is important if you really want to know how to do statistics properly. Okay? So don't base your entire statistics career off of this video or the videos that will follow. Okay? But if you're in a class where it's okay to maybe cut some small corners when you're doing statistics, this will help. But keep that in mind, okay? Don't use this and apply it to situations in which it's very important that your statistics be done properly and then come back crying to me and say, well, I followed your video. And as a final warning, Game of Thrones spoilers may appear. Alright, so let's get started. Let's talk about the t-test. Say you want to compare the means of two samples. Right? You want to see which, if the samples, one of them tends to have larger numbers than the other, this is when you would use a t-test. Alright, so here we are. Let's take a look at our data in Excel. So let's say we have two reefs, right? Two coral reefs, and we've measured the lengths of fish of the same species on the two coral reefs, Reef A and Reef B. All right, here are the lengths of, these are our samples from both reefs. So, I mean, the first thing we would like to do is let's take a look at the averages, or what we would call the means. All right, so I'm going to select the average for Reef A. Let me move that down a little bit. Let's just copy these over here. It's always good to have the labels. So this is the average for all the data in column A. And I'm just going to go ahead and drag that over here. And that's the average for all the data in column B. Okay, so Reef B has a higher mean fish size. The fish on average in our samples are longer. Now, we can't necessarily say if all of the fish on the reef are longer because we've only gotten a portion of them, right? We have a sample. We don't have the entire population. We didn't measure all of the fish of this particular species on reefs A and B. And that's where statistical tests come into play. Something else we're going to want to have is the standard deviation. So we can calculate the standard deviation by using this formula. We want the standard deviation of the sample. Okay, so we want STDEV.S. There are other ways to calculate standard deviations, but this is the one that we want. And we want it of that group there, and we'll just copy it over here. This gives us an idea of how spread out the data are. So the data in Reef B are more spread out than the data in Reef A. And if we just do a little quick figure here, let's see, will this work? This will give us what we want. Right? This is not the type of figure that we're going to want, right? But this just gives us a little bit of an idea. If you compare Reef B to Reef A, the orange ones tend to be higher than the blue ones, and there tends to be a bigger spread. This is not the way you want to present these data, so let's just get rid of that for now. All right, but what we really care about is, are the fish in Reef B significantly longer than the fish in Reef A? And to do that, we are going to use our t-test. All right, so what do we need to do? We need to come here to data. Now this is done in a Windows computer, so if you've got a Mac, some of this will be slightly different. Google it. I'm sure you can figure out the slight differences, but most of it is going to be the same. So let's go to data, and we want data analysis. It's over here, or at least it should be, but it's not present. So if it's not present, now we have to go to File, Options, and we want add-ins. See right here, add-ins. Click add-ins, and we come down here, it says Manage Excel Add-ins, go. Boom. we want the analysis toolpack. We click there in the analysis toolpack and hit OK. Boom. And now data analysis pops up here. Okay, so now I'm ready to do my t-test. And what I do is I come up to data, come over here, and it says data analysis because I've added that Excel add-in. I click data analysis, and if I scroll down there, I see there are three options for t-test: paired, two sample equal variances, two sample unequal variances. Unless you know what you're doing, go two sample unequal variances. Okay, we're gonna hit OK. Variable 1 range. I select everything, including the row label. All right, that'll be parent Y in a second. I select variable 2 range, and I click labels here because I clicked on the labels, and it's always good to include the labels. Output range, I like to put the output in the same sheet, so I click output range, and I click here, and then my data, my results were going to come down and to the right of that. Boom. So here are my results. Alright, so the means, look here, the means are the same as I calculated. Variance is similar to standard deviation. It's in the same ballpark, but it's a different statistic. I have 16 fish per reef. Here's what I'm going to need to report in my results: the degrees of freedom, the t-stat, and the two-tailed p. Degrees of freedom is essentially how confident you are in the test to some degree, right? So the more samples you have, the higher the degrees of freedom. The t-statistic is the statistic calculated by the test. Okay, so the test, what it does is it calculates a t-statistic and then says, what's the probability of this particular t-statistic given my degrees of freedom? Here's something that Excel is always getting wrong. It is always getting wrong that the t-statistic must be positive. There should never be a negative. I should spell it right. There should never be a negative t. Okay? So if it gives you a negative t, just make it positive. Ignore the negative. And down here, this is the thing that you really want to look at. This is your two-tailed p. It's the probability of the test. And essentially, if p is less than 0.05, then there is a significant difference between the samples. Okay? In this case, our p is 0.0398 for the rounding, so it's less than 0.05. So what we can say is that there's a significant difference. We are confident enough that these samples are different enough that we can say that all of the fish on reef A are smaller than all of the fish on reef B. Okay, so how would we report this? All right, this is what you have to write in your papers. So you could write it like this: this is in the results section, and results should always be in past tense. There was a significant difference in length. Yeah, that's nice. What's a better way to write it? What's a more succinct, more direct way to write it? The fish on reef B were significantly, excuse my spelling, were significantly longer than the fish on reef A. Alright, but that's not everything that you need. We gotta give, we have to give our results. So we could say the fish on reef B, and with parentheses, and we actually give the means. So 13.456 plus or minus, and then we have to, if we give a mean, we got to give the standard deviation or standard error or something like that. 5.59. 59. two fives. What units? Centimeters. And we gotta tell them what these numbers are. So this is the mean plus or minus 1 standard deviation. Okay, so someone reading that knows that we're talking about this is the mean length plus or minus 1 standard deviation of the fish on reef B. We're significantly longer than the fish on reef A. Let's report the same thing. 9.806 plus or minus 3.842 centimeters. And since we've already told them that since we've already said that this is the mean plus the standard deviation, we don't have to repeat that. But we say in here we're significantly longer, so we have to, see right here, significantly longer, we have to justify how we can say it was significantly longer. So this is where the t-test comes in. So we tell them we did a t-test where the t is equal to positive 2.160. We have to report the degrees of freedom, 27 degrees of freedom. We have to report our p. P is equal to 0.0. Let's report just the 3 decimal places, so we have to round it up to 40. Okay, and so what this does is it lets someone reading the text know all the information they need. What's the size and standard deviation of the fish on reef B, size and standard deviation of the fish on reef A, and you say that they're significantly longer. What's your justification for that? You did a t-test, and these are your statistics, and the p is less than 0.05. Some people will love to wax poetic about the statistics, and they'll say, I performed a t-test, and the t value was 2.160, and there were 27 degrees of freedom, and the p was equal to 0. You don't have to do that, right? Be to the point, right? This has the same information that you would have if you wrote all that other stuff, but it's much easier to read. Now, something you might do is you might stick all of the data in a figure. So we can get rid of those. We don't have to report the means there. We don't have to report the means here, but we have to tell them where to go look for it. So we could say figure 1. So the fish on reef B were significantly longer than the fish on reef A. Where can I see that? Oh, figure 1. I'll go look at figure 1. And then I justify the significantly right there. So that's how you would report it in a lab report or something like that. Okay, makes sense? All right, what if our results are not significant? Okay, what if our results are not significant? So let's look at 2 other reefs. Here are 2 other reefs. Still, the averages of the samples, the means, are different. This one's almost 3 centimeters longer on average than that one. But we got to do the t-test. We have to do stats to see if there's a real difference in the fish in nature. So, data analysis, our t-test again. Now, it's going to give us the values that we already had. All right, so we don't want any of those, so let's just delete those. Okay, and then we'll come over to here. Our variable 1 range is going to be reef C. Variable 2 range will be reef D. Now I know I'm probably moving kind of quickly, but this is a video. You can pause it and jump back and forth. Labels are checked. Output range, put right there. And what do we have? So what's important are degrees of freedom, our t-stat, and our p. Okay, in this case, our p is greater than 0.05. So we would say that there is no significant difference. Or we would say the difference is non-significant. You wouldn't say insignificant, right? If you're doing stats talk, it's always non-significant. So what would we write? We would write there was no significant difference in length between the fish of reefs C and D. Now we have to justify it. So we say t-test. What is our t-stat? T is equal to 1.834. Remember, it's always positive. 27, put comma, 27 degrees of freedom. And our P is equal to 0.078 with rounding. And I spelled significant wrong. Please forgive me. Boom, that's it. That's our results. Now maybe you have a figure. Okay, so maybe you say figure 2. Okay, maybe you do, maybe you don't. But that's all you write. And here is an important point. If you find no significant difference, that means there's no difference. Okay, you can't then start to write about how, well, D was kind of bigger than C and maybe it was bigger. No significant difference means, for all intents and purposes, they're equal. Okay, maybe you got to go collect some more data if you really want to find a difference, but guess what? As far as you know, they're equal. So don't pretend that there is a difference at this point. But that's the key. If it's greater than 0.05, no significant difference. If it's less than 0.05, then there is a significant difference. Right. So, what are some other things to consider? T-tests are only for 2 samples, comparing one sample to another. What if we want to compare the means of more than one data set? Say we have 5 reefs that we want to compare. Okay? One thing you could do is you do multiple t-tests. You can compare reef A to B, and then to C, then to D, then to E. And then you can compare reef B to C, then to D, then to E. And then reef C to reef D, then to reef E. And then D to reef E. That's a lot of tests you got to do. So it's a pain in the butt. And it's also technically illegal when it comes to statistics, right? So that's the wrong approach. You do not want to take that approach. If you don't know how any other way, okay, then you can probably do that. But that is ideally the wrong approach. What you should be using is something called an ANOVA, which would be a subject of another video. All right, that's it. Hopefully you got it.